Okay, in this video we're going to be putting together a very simple keyboard application to give you an idea of working with the keyboard state. First, let's go ahead and take a look at the keyboard state. So let's go ahead and bring up a new page real quick, and we'll hide this guy out. So keyboard dot get state. So keyboard.getState returns back to us a keyboard state. So that is the type that we're going to be working with. And like I said, it is a struct. Kind of think of it as a lightweight type class that has properties and methods, etc. So let's take a look at some of the important keyboard state members. Item. So item is going to return the state of a particular key. Is it up or is it down? Get pressed keys. So get pressed keys array. Basically, this guy is going to return back to us an array of all the keyboard keys that are being pressed at that moment in time. Is key down? And with is key down, since we're looking for the state of a particular key, we need to send it a key. Now, we're going to be dealing with the keys enumeration that is set up for us by the XNA framework. So basically, send something like keys.a. So in this particular case, I am checking, or I am asking the keyboard state, is the A key down? And is key down is going to simply return a bool, true or false. It is or is not down. And finally, if we have an is key down, we've got an is key up. And same thing. Keys, let's say I wanted to check the X key. So here we are asking, is the X key up? So we've got basically a property, and then we've got a series of methods. With this method here is going to be returning an array back to us. So I'm just using that to indicate we get an array back, okay? Which is multiple keys. So once again, we're still dealing with our keys enumeration that you're going to see here in just a second. And of course, IntelliSense is going to make working with keys very, very easy. Now, Logan is going to slowly start building up this keyboard application, but by the very end, it's going to be a very simple program that's going to do the following. It's just going to have some simple text written out to the screen. So it's going to say continuous and toggle. And we're going to have two boxes drawn. So you're going to get a whole lot more out of this than just detecting keyboard states. They're going to do a little bit of graphic stuff. So we're going to have Z and X will be the two keys we're going to pick on. And so the idea is when we hold Z down, we're going to get a continuous lit up box with Z in it. And when we hit the X key, it's going to toggle. So we hit the X key, let's say it's off right now. We hit the X key and we hold the X key down. It turns on. We let the X key go. It stays on. So the idea is to toggle it. We press the X key again and then it turns back off. So that's the idea, to have it toggle. So to demonstrate the difference with continuous and toggle, where toggle is going to have to do that state comparison that we talked about in the last video. So very simple application. Logan, with that, let me go ahead and turn it on over to you. Let's show them how we can start using the keyboard's keyboard state.
All right, let's get started. Let's begin in Visual Studio, and let's start a new project for this. Let's make a Windows game and call this Input Keyboard. And with our new project created, I'll begin simple. I'm going to make a sprite batch and a sprite font. So we can begin by showing the input using some simple text. We'll get the states and then just draw text as necessary to display whatever we want to see what is happening with the input.
Okay.
So, I'll start with my sprite batch. I'll make a sprite batch field and simply call it sprite batch. All of this should be familiar from the sprite batch lessons.
Okay.
And I also want a sprite font field. I'll call this, I'll leave this simple. I'll simply call it font.
Okay.
So we have a sprite font and a sprite batch field. Now, of course, in initializing, I need to remember to create the sprite batch. So I'll say that sprite batch is equal to a new sprite batch object where we feed it our graphics device. So we'll give it graphics.graphicsDevice, and now our sprite batch will be ready to use after initialize is run.
Okay.
And now we get down to load graphics content, where I wish to load in the font. Now, up until now, I have not yet created a font, so now would be a good time to do that. I'm going to store the font in a textures folder, and later I will actually need some textures. So I'm going to create a textures folder, and then to that folder I'm going to add a new item, and I wish to add a sprite font. As we'd covered in the text drawing lesson, of course, we could just give a name of a desired font. So I'm going to give it Tahoma, so I'll leave the name be Tahoma.SpriteFont. This will create our font. The name is set to Tahoma. I have a specific font size in mind for the graphics I've put together, so I'm going to change the size to 13, and I'm going to set the style to bold.
Okay.
And that is what I wish to have for the sprite font. So I'll save that out, and I can go ahead and close the sprite font itself. Now we have the asset prepared, and I can load it in to the font field, which is as simple as font equals content.load. I'm going to be loading in a sprite font, so we'll give it sprite font for the type, and the asset will be the textures folder / Tahoma. So I'll, of course, do the add symbol for literal string. Then we'll give it textures / Tahoma. And that should have our font asset loaded in and available within the font field. So with a font ready and a sprite batch available, we can do the rest of the testing from within Draw.
Okay. The idea, of course, just keep this as simple as possible, just straight to the point.
Right. So that I don't have to worry about the sprite batch too much, I'm going to put together its begin and end methods, and then we can finally take a look at input.
Okay.
So I want to make my sprite batch.begin call, and then maybe give an empty space, and then my sprite batch.end call. And then inside of here I want to draw a string, but I want to draw a string. Here's the idea. Let's start simple and pick on the Z button.
Okay.
Let's just make a setup to where as long as the Z key is held in, we simply get the text Z is pressed on the screen.
Okay, sounds
Let's
good.
set up that scenario. That means, of course, we'll need a keyboard state, because we need to get the keyboard input for the Z key. Now, in order to hold the keyboard state, I'm going to make a variable of type keyboard state, and I'll simply call it keyboard state. So keyboard state, much like you had drawn on the whiteboard, actually. Now we want to go ahead and immediately initialize this keyboard state variable to keyboard dot get state. Of course, it takes in no parameters, and after executing this, this is the line where we're doing our polling. This polling of keyboard.getState should store a keyboard state within our keyboard state variable. And now we can turn around and use that. As long as we've pulled the state and stored it in keyboard state, I could go back to the sprite batch section and do an if statement. And inside of that if statement, I could check keyboard state dot is key down. And then to is key down, I need to feed that a specific key. It's expecting an argument of type keys, which is a pre-existing enum. So if we access that enum, we can see it holds a whole bunch of definitions for different keys. Scrolling through this list, we can see all of the keys that are available from the keys enum. Since I'm interested in the Z key, I'll feed it keys.z. And that finishes off the call. Another parenthesis finishes off the if statement. So if that is true, if the Z key is down, then I wish to make a call to drawString. So we could say that the Z key is down. So we'll make our call to sprite, with lowercase s, sprite batch, .drawString, and I'll draw something like, let's see, the font we have stored in the font field. The text will be Z is pressed. And let's see, position, vector 2. Yeah, we could do, I was going to do 0, but offsetting would just make it look nicer.
Yeah.
So we could do a new vector 2, and we could feed it an offset of 10 by 10.
Okay.
And then finally for the color, for now I'll do color.white, though I do want to define some custom colors because I'll need to use those in conjunction with the graphics. Since I don't have them yet, though, I'll use the color white. And now, if I haven't introduced any errors, I should be able to build. So I'll build just to check that, and the build has succeeded. So now we can run and test. So we get the standard background color. If I press the Z key, we get Z is pressed. If I release the key, the text goes away.
Because, of course, with each draw iteration, it basically clears our screen first.
Exactly. So as long as the Z key is not held, is not down, then that if statement is false, and the text is simply not drawn. So we see the screen get cleared out. But I mean, that's really basic input handling. We're polling for the Z key, and as long as it's pressed, we represent that with text.
Okay.
Now, before I go any further, I do want to take just a second and set up the colors that I'll be using in the end for the final graphics section, and that is to make the screen clear color black. And I wish to set up some colors for what I'm going to term a foreground and background color. Foreground will be immediately apparent. Background is something I'm going to use in conjunction with the graphics. So I'm going to define two colors back up as fields. I'll make a color, the first one called forecolor. And I'll set that to be equal to, now what's interesting with this one is I don't want to use any of the pre-existing colors in the colors enum or the color struct. So what I want to do is make a color where I can specify RGB values. And this is very similar to the sprite batch blending sample where we created our own custom color that had a custom alpha.
Mm-hmm.
And I did that by using a new color, and color will allow me to specify a red, green, and blue byte. So this will let me access custom bytes to get a custom color. The color I had in mind was bytes red 166, green 206, and blue 57. Now I'm also going to define a background color, so I'm going to copy and paste this line to get a second color line. I'll call this one back color, and I'll set it to a value of 98, 127, and 21. And now let me put that foreground color into use in the text drawing. So I'll replace color.white with forecolor. And forecolor is...
Gotta press Z. Gotta press
Z.
That was
there
good.
we go.
Yes.
And I've, but now we've got a greenish yellow style color.
Very nice. That old computer look.
And these are the colors that
Monochrome.
I'll continue to use when we get into the graphics section.
Okay.
But now that we've taken a look at very basic key press, let's see. At this point, we can either look at state changing or we can look at the keys, get press keys array, because you had mentioned on the whiteboard get press keys.
We can look at that real quick. That's a little extra for them.
Or even before that, let's do multiple keys. That's what
sounds good.
Reminded me of it. Let's do a test to say, what if we had a scenario where we wanted, since we're picking on Z and X, we could do Z and X, or, I'm just thinking here for a second, maybe Alt-Enter.
Okay.
So we'd use that as an example. What if we wanted a state where we wanted to say Alt-Enter is pressed, but not have that state fire if only Alt or only Enter is pressed? We wanted to have both. Now, all that is going to be really is an if statement where we check for both keys. So if I wanted to do a check like that, I could replace Z with keys.Alt, though you'll notice that each individual key is mapped. If you look through the keys array, so there is no such thing as Alt by itself. It is actually left Alt. And since that one's farther away from Enter, I changed my mind. I'm going to use right Alt because I can press that more easily.
Okay.
So we'll check right Alt, and we'll make the check for if right Alt is pressed and keyboard state dot is key down, and then give it keys dot enter. So there we're checking for both keys to be pressed, and if that is the case, we can say Alt plus Enter pressed.
Okay.
So now if we run, we can press the Alt key. So pressing Alt over and over again, we get no output. Press the Enter key over and over again, we get nothing. If we hold both Alt and Enter at the same time, there we go. So that's a very simple method of detecting multiple keys.
Mm-hmm.
And this is limited only by what keys can be pressed physically on the keyboard. Of course, more than 2 is allowed in many cases, but you do have to keep in mind that there's a hardware limitation of keyboards where certain key groupings are set up such that you can't get 3 or 4 keys in certain cases, just basically because of the way keyboards are wired.
Okay.
But keeping that in mind, that is just a limitation of physical keyboards, not so much of the keyboard state. But with that in mind, with multiple keys, another thing to look at is how we would get all of the keys that are currently pressed if we wish to have that simply given to us. Instead of having to look for keys individually one by one, we could take a look at get press keys and then working with the array that it returns. What we could do is, let's see, where do I want to store this? I want to make a keys array variable. So I could do something like keys array, something called keys. And we could say that this array is equal to keyboard state dot get pressed keys. So now I've taken this one step further where we had the keyboard state set to the get state. Then we turn around and say that the keyboard state dot get pressed keys now returns keys into a second variable. Now with the keys array, we could loop through that. So I'm going to take out my if statement check altogether and instead put in a for statement. So we'll grab for, I'll grab the template just for brevity's sake. So 2 tabs on the for template, and I'll use I for the index variable, and then for the control we could say as long as I is less than keys, just thinking for a second, dot length. Alright, and so for each line in here I want to write out what key specifically is pressed. So I'll steal that line where I was doing the drawstring, I'll paste that in and then just modify it slightly. Now for the value, since I don't want to do a further statement to check, I could cheat lightly and give it keys I, so which element we're looking at, dot toString, and just let it take care of it. And let's see, looking over this. Now we will need to offset down because if we draw multiple keys over each other, they will just literally draw over each other. So what I'll do is I'll take maybe the Y and set it to something like I times, I think my height was 13 and then I had some spacing, so I'll put in 15.
Sounds good.
So every subsequent line will draw one line down. And I'll build just to check for any simple errors. And if I have put everything together correctly, we should get a result where we could hold a single key down and we get that key's textual value. But then we could hold multiple keys down and see them get listed. So we could do Z, X, C. And you'll notice that the order in which they're displaying is the order that they are within their enum, not the order that they were pressed. So if I press the Z key followed by X, then followed by C, you see C is jumping to the top. If I try to reverse the order and do C first, then X, then Z, that's
C
not actually
stays
changing the input order.
Right.
So I mean, this could be useful for any variety of reasons if you want to have all keys that are available. Like maybe in a certain state you don't want to risk missing a key press, or whatever you might need all these keys for. Or even just to show you what keys are available or what keys are getting pressed. Like what is the explanation for that key that is next to the right control. So there I'm pressing the right control key, the key next to it with the arrow that brings up menus and windows. Okay, that was apps. So if you didn't know to look for that within the enum, you could do a loop like this and find out what key that is. And of course a lot of these keys are going to have full textual names. So if your goal was to do some type of keyboard text input for a game, you would probably need to remap these to a better ASCII or char set representation, because the number keys, the number key 1, 2, and 3, are actually being represented as D1, D2, and D3.
Right.
But that is just an example of what get press keys can be used for, and how one can go through and walk through all of the keys returned by a get press keys call.
Right.
And let's see. So I think that's looked at multiple keys just using an if statement, and then multiple keys using a get press keys. Now I think it's time to take a look at that graphics routine.
Sounds good. And
show using the key value, but then handing it off to a different routine. Then after that we can take a look at toggling.
Okay.
So quick divergence, if you will. Now we're going to make a method that will draw in a graphical outline of a button and then highlight that button if it's been pressed.
Okay.
Now since these are going to be graphical, that means I need some graphical assets. We've created the textures folder here, which means we should have a textures folder in our project, but I need to get some source art, some actual source files. And I've got these here in our temp working directory. I've got a fill graphic, and a quick explanation of these is that the fill graphic is a simple 1 pixel by 1 pixel white image. The button is, I forget the dimensions, I think it's 20 by 20 roughly, and it's a simple thin bordered button. So it's a thin frame, almost like a small box-like button. And the idea is that I'm going to stretch the fill image to fill whatever size that I need. So with these graphics, I'll simply copy them. I need to bring up my projects folder. There's the input keyboard project we just created. And inside of that, there should be a textures folder with our sprite font. So I'll simply paste these graphics alongside the sprite font and then add them into the project. So we'll add existing items. We'll jump to textures, switch to content pipeline files, and bring in the button and fill PNG files. And before I draw them, it'd probably be a good idea then to get some fields ready inside of our class so that I can load them and hold a reference easily. So I'm going to make two texture 2D fields within the class. I'll have a texture 2D called button and a texture 2D called fill. Now with these fields, I want to make sure that they get loaded at load graphics content. Since most of this line stays the same for the content load line, I'll simply copy and paste it, changing font to button, changing the type to texture 2D, and changing the asset itself to button. And then I'll copy that line, paste again, and we can load in our fill field. Still a texture 2D, this time from the fill asset.
Okay.
Alright, that has graphical assets taken care of. Now we can look at the method. The method I want to create, I'm going to call drawKey. Its purpose is going to be to physically draw that button representation of a key at a given position, then to take in a boolean to tell whether or not it should shade that button as pressed. And then it's also going to take in a string label in order to lay some kind of label over the button. So this is going to be a private method. I'm going to return nothing, so we'll set its return type to void, and I'm going to call it drawKey. Now things we need to take in are the position. So we'll take in a vector2 called position. Then I want to take in a boolean value called pressed. Small spelling.
It was close.
There we go. And finally a string label. Alright. Now, this button, if you will, is going to be drawn in layers. I'm going to have a kind of fill layer that I'm going to put on the far background so it doesn't ever overdraw the actual frame. So I'm going to draw this fill. Then on top of the fill I want to draw the frame, and on top of the frame I want to draw the label.
Okay, the label being X or whatever,
right,
whatever
yes,
text you want in
whatever
there.
was given in the string label.
That's right.
So the only reason I hesitate for a second is because the fill is the most complicated draw call out of all of them. Just to get an idea of where we're going visually, let me put in the frame and the text first, then we'll get the fill working behind it. So what I mean by the border is to do a call to a sprite batch draw and to draw out this button graphic.
And obviously, let me throw this out there real quick. Of course, calling upon the drawKey method, we're going to stipulate that this is going to take place between a sprite batch.begin and a sprite batch.end.
Right, we're going to leave that up to the responsibility of who's ever using this method.
That's right.
But that is good to point out that if you call this arbitrarily somehow outside of a sprite batch begin and end, then yes, you will very quickly get problems.
Yeah.
Alright, this one is going to be drawing the button. So I'm going to feed it the button field for the texture 2D. I'm going to feed it the given position for the position parameter. And I'm going to give it that for color that I had defined at the top of the class. And then I can turn around and also draw the label. So I'll make a call to sprite batch draw string. We'll draw with the same font. So we'll give it the font reference. We want to draw the text held in label. We want to draw that text at the position but with an offset. So I'm actually going to give it a new vector2. So I'm going to base that vector2 off of the components of position. This is going to be a vector2 for position.x, and I'm going to offset the position x by 4. And while I am plugging in magic numbers here, this is just because I've seen this graphic and I've come up with a number that puts the text properly inside of the graphic. So I'm going to take the position x but offset 4 and the position y and offset that by -1. And then I wish to draw the text also with the for color. So we'll plug in for color, end that off, and now we should.
Can I show him something real quick?
Sure.
I was just going to. The reason that he's done that is because basically, remember, drawing out a button right here. So when we come in here and we draw at a given position, and there's the frame that Logan was talking about, the button. The last thing we want to do then is come over here and draw our Z, starting at the exact same location. So instead, that's why he's moving it over by 4 and down by 1, so then we end up with something that looks a lot more like this. And also, when he was talking about drawing in layers, that's another thing, is he was talking about the first thing he wants to do is basically shade it, which is the fill, which he's going to get to in just a second. And then over that, he's going to draw the frame. And then over that, the offset label. So we'll end up with something like that if it's shaded. I just thought that might help them with what you were doing.
Right, just to get a preview of what exactly this is supposed to be doing.
Exactly, but you can see there why he offset it. That was pretty important.
Right, and why I just came up with some random
magic
seeming numbers. Exactly. So while this is still lacking the fill, I do want to go ahead and put a call into draw key so we can see what we're working with. Also, I'm entirely done with the get press keys and the example loop, so I'm going to rip that. I'm going to rip that entire loop out and the keys array out.
Okay.
So now we're back to a simple keyboard state and a sprite batch begin and end. So now I'll jump in just after the sprite batch begin and make a call to draw key. And I wish to draw a key at, for now, I'll give it a vector2 dot 0. I have this will have a different alignment, obviously, if I'm drawing text before to represent continuous and toggle. But for now, let me do a new vector2.
And do it at like
10, 10 again.
Okay, that works.
So we'll give it a vector2 of 10 by 10. Pressed state, I'll just set that to false. You'll notice inside of draw key we aren't even using that yet. And a label of the string z. And I'll build, make sure that so far there's no errors, and run just to demonstrate that's what the graphic is looking at. That button graphic is that border style look, and then the text Z is being drawn inside of it. And
you can actually see now the 1 pixel over, or 4 pixels over and 1 pixel down too.
Right.
All right, so very cool. So now we've got the frame and the label being drawn, so let's go ahead and advance into getting it shaded now.
All right, being shaded is going to be based on this pressed parameter. So that means before we even attempt to draw a shading or not, we want to check that value. So saying if pressed, then we wish to draw the shading. Otherwise, we don't.
Right.
Now, the shading is going to be based on this fill graphic. And as I said earlier, the fill graphic itself is a 1 pixel by 1 pixel file.
But when we took a look at sprite batches, we saw how we could take that and specify an entire area to basically draw out like a rectangle.
If we used the destination rectangle, we could stretch any source texture we wanted to fit any size that we wanted. That means we could use existing width and positioning numbers, make a new rectangle, and then position that one graphic stretched out to fill the new rectangle.
Okay.
So, if pressed, we're going to begin this all off with a sprite batch draw call. We're going to be drawing the fill texture, so I'll give it the fill reference. And then we'll use a destination rectangle. And here I'm going to make a new rectangle. And a rectangle is specified in the formula x, y, width, and height. The x and y are going to be position vector 2, or they're going to be based on it. Though I do want to offset it a little, since the edges of that box graphic are kind of rounded. So if we draw out to the edges, we'll actually see the corners of this rectangle. So it's like I need to shrink the whole rectangle
just by
a little
1
bit.
pixel, yeah.
So what it's actually going to need to be is the position dot x, since we're filling in x for the rectangle, plus 1, so we move it 1 off the side. Now another thing to keep in mind is position.x is a float. Rectangle takes in an integer, so we'll need to cast this to int before it will be able to be stored in the component of the rectangle. Next we need the y value, so same idea here. We're going to cast to int the position y, but offset that by 1. And then next we have the width to specify. For width, I'm going to use the actual button graphics width. If we look at that button reference, one of the properties of a texture 2D is width. So we could take the overall button's width, but I want to go back in a pixel on this side as well. -1 is the first thing that comes to mind, but you have to remember that we've already offset by physically moving it. So I'm going to bring it back in by 2.
That's
so
right.
we both offset in and then counter for the movement offset.
Right.
And then finally I need to specify a height, which we can get from button.height, and again -2. So we move in and counter for the positional offset. And that takes care of the rectangle, leaving only the color. And the color for the fill is going to be the back color that I had defined earlier. There. A lot of stuff going into the rectangle, but that should properly draw a rectangle at the correct area.
I thought it was actually quite straightforward. Now, of course, running it at the moment, it's not going to do anything because right now when we make our call, we're just pumping over false, so there's no way for it to ever be set to true.
So really, we should plug in something that's relevant to the keyboard state.
Yeah.
As a matter of fact, we could plug in a call to keyboard state.is key down, and then feed it keys.z, since that was the original key we were interested in. So this is key down should return a boolean, which is exactly what we need to feed here. So let's run, and then we have our graphic being drawn still, but if we press Z, we can see the button light up as that background fill graphic gets drawn to the size of the button. So, I mean, really, it's that simple. I just wanted to show using some type of graphical system, but then have that system influenced by keyboard input.
There you go.
And of course, the little bit of work on the rectangle, but that does make it adaptable, so that if in the future this button graphic changed in size, then the fill graphic will simply go along with it, and it'll be recalculated by the button's own dimensions.
Right. Okay, so now let's go ahead and enhance this. Let's make it look a little bit nicer. We'll go ahead and get X into place, and then we'll put together the toggle.
Okay. So for, let's see, visual enhancements, we want to make sure we write down the words, the actual word continuous and the word toggle, and lay this out like you had originally drawn on the whiteboard. So before we draw the key, we're first going to make a call to draw a string. So that is spritebatch.drawString, again using the same font. This time drawing the text continuous. The Z button is going to be the button to demonstrate the continuous usage. So this will be continuous, put a colon, end off the string, and then the positioning is going to be a vector 2. So I'm going to make a new vector 2, and I'm going to specify some numbers I determined. Just based on the size of this font and these graphics, I had come up with the position 10 by 8 for the continuous text. And I'm going to draw the text with the foreground color. So we'll plug in 4-color. Alright, so we draw continuous. Now we have some actual numbers that we need to plug in for the draw key call. And that is 125 by 10. And now we want a second version of this, a new line that has the words continuous with the X button. So I'll begin by simply copying...
Or toggle. In the X
or, excuse me, the toggle button. So copying and pasting these lines. So we have the X button, which is going to be toggle. And the position for the toggle line is going to be at 10 by 33. Then the position for the X key is going to be 125 by 35. And the key we're looking for is keys.x, though really I'm going to be changing this in a second. This is just going to duplicate the functionality. But so we'll put in the label X. We could even run and show the positioning now that we have our screen drawn properly. We have the Z button. We also have the X button working, but not as a toggle. And obviously not because we plugged in the exact code that we had from the Z key.
So when you're holding X down, it stays lit up. The moment you let go, it's no longer lit up. So we want it to toggle now. So when you press down and then let up, it stays lit. When you press down, let up again, it becomes unlit. Toggles.
All right. Let's take a look at doing that. If we want a toggle state to be remembered, we know going into it that we're going to actually have to have a variable outside of the draw method, because as the game continues to run, we want to remember what the toggle state was. So I'm going to jump all the way back to the top of the class and define a toggle field as a boolean. So I'll make a bool toggle. Then down in the input section,
do you want to go ahead and define the last keyboard state as well?
I want to get into that in just a second, because I want to show what happens if we try to do this without a last state.
I gotcha. You're going to show them flickering.
So yeah, we're going to try to do this in a simple method, because it might not be immediately apparent that you need to use state switching to get this effect. You might think that, well, I'm remembering a toggle value, wouldn't that be enough?
Yeah, I agree. Good idea.
So now with this toggle value, what do we want to have happen? Well, the idea is that pressing the X key causes the toggle to reverse its value. So let's lay that down simply with an if statement. So if keyboard state dot is key down, and then we're looking for keys dot x. So if that key is down, we want to flip the value of toggle. And this could be done really quickly by doing something like the value of toggle is equal to not toggle, because of course the not operator is going to reverse whatever value is held.
So if it's true, it just became false. If it's false, it just became true. Right,
and with it being by default initialized to false, it means the first time we press X, we should have this be not false, which would mean true gets stored, and that was the proper flip, and then vice versa next time we do the check.
So now all we need to do is take toggle and feed that into the call to draw key.
So we'll replace this keyboard state with toggle. And I mean, just looking at the code, just following through, it seems like that should work just fine. But let's run now and see what result we get. If we press and hold the X key, we get this kind of flickering result. Now the flickering is kind of minute and hard to see, but the effect we're getting is that we have a background color that's not as bright. So for reference, there's how bright the Z key was. The X key looks more dim. Also, depending on what moment I release the key at, sometimes it stays lit. So in some cases, we can press the X key and get a lit state and it remains, but not always. Sometimes, let me see if I can get this going, where it'll stay lit, and then even after being pressed again, remain lit again. So what's actually happening? It's as though holding the key down causes it to flicker, and then releasing the key causes it to randomly go to either filled or not filled. So it's like a very incredibly unreliable toggle. But really what's happening is it's a flicker and then just a draw of the hat if you release the key at the right moment for it to be undrawn.
Right.
So let's take a look at what's happening. The check that we're doing is just if the key is down. And that means, as you were saying earlier, that if we hold the key down, every time we draw another frame, the key is still down, and we still run this flip. That means every call to draw, we flip toggle. And that's where we're getting the flicker. As every single time we draw, we change the value. So we go from toggle to not toggle. So for drawing the fill to not drawing the fill at the full draw rate.
So as long as you're holding that X key down, in 1 second's time, you had 30 lit ups and 30 not lit ups.
Exactly.
Yep.
And that's not what we want. And this shows why we would need to do state changing. Because in order to avoid this case where we continuously flicker because the X key is continuously down, we now need the ability to tell if the key was only pressed. Because if it was pressed and then we stop setting it, then we'll catch exactly one key press, flip the toggle, and leave it alone until another key press is detected.
Okay.
So let's take a look at doing that. As you had drawn earlier in the loop example on the whiteboard, we know we need a keyboard state that's held outside of draw, something that we can look at as last keyboard state. Because all we have available inside of draw is just what's available at the moment. Any local variable, just by nature of variables, is going to be lost as soon as we lose this method call. So we need to have the last keyboard state survive until the next call of draw. So I'm actually going to put this keyboard state back up as a field in the class. So I'm going to make a keyboard state field, and I'll call this last keyboard state, like so. So now what we can do is, let's see, back down in our drawing. I guess what I'm thinking of here for a second is we could initialize it in initialize, though technically because it's a struct, in theory everything should just be all at their unpressed state. So either way, depending on whether or not the very first tick of the game is important for input, I mean, we could do something like inside of initialize, say, last keyboard state equals keyboard.getState, and certainly won't hurt anything. And if for some reason that first tick is important, then we might have some actual keys stored. It shouldn't make too much of a difference for this example, but I mean, it can be done as a
It just goes showing initializing our variable.
Sure. And now that we have the last keyboard state, we can do a check against it to say if the current keyboard state has the key X held down, and the last keyboard state has the key up X, so keys.x. So that means if coming into this now we get the current state, we find that the key X is down, and on the last update, X was up. So if it was up, it just became down, it was just pressed, so we go ahead and toggle. Then after that, so once we're done handling input, we make sure that we set the last keyboard state to keyboard.getState again. As a matter of fact, I'm going to set it to directly to the other keyboard state value, so basically sync the two states together. So this was current state. We do any kind of input code, and then at the very end, we set last keyboard state equal to current keyboard state.
Yeah.
So now at that point, they're in sync. So if we retrace this again now, we hit this line, and if the states were different, we cause the toggle to flip. But then we sync up the states. So on any subsequent calls where now the key is down, so the key is still down, but the last key is down, so is key up would be false, and this wouldn't be run.
That's right.
So we only issue this once per key press. So let's take a look at the example now. Now if we press and hold X, you can see it stays lit to its full brightness. And if we release X, it stays on properly. If we press it again, it goes off, and then releasing it, it stays off. And now it's reliable. So one press results in the toggle on, one press results in the toggle off. And so as we press the button, we can see it reliably turns on and off as a toggle. None of this flickering and none of the randomness.
Very nice.
So really, that's what I wanted to demonstrate in the keyboard example. A continuous key very simple input, and a toggle key, which requires a toggle variable and a last keyboard state in order to back it.
Okay. So if we close that out and we jump back over here real quick, that just kind of following through with our whiteboard. Did I manage to just swap those? No, it looked like I did. So that takes care of this guy over here now. And next up is going to be the mouse app. So that's going to wrap up this video. Thanks a lot.